Let's be honest, when you think of an oil refinery, you probably picture this huge, sprawling complex of pipes and smokestacks, right? But what if I told you that inside that industrial maze, there's a high-tech revolution kicking off? Today's refineries are transforming into these incredible hubs of chemistry and data science, and we're going to dive into how they're pulling it off. At the end of the day, it all boils down to this one huge question. How do you take this raw, black, sludgy crude oil out of the ground and turn it into the super clean, high-performance fuels that our entire world runs on? Well, as you're about to see, it's a whole lot more complicated than just boiling it. The story of the modern refinery really plays out in two big parts. The first is this constant, massive, and kind of hidden cleanup operation that's happening inside those walls 24/7. And at the exact same time, it's in a desperate race to completely reinvent itself for a low-carbon future. So here's our roadmap for today. We're going to start with that incredible deep cleaning job they have to do. Then we'll get into how they're pivoting to become more like chemical factories, how AI is changing the game, and finally, what new green fuels could shape their future. Okay, first up, the hidden cleanup. And look, this isn't about scrubbing smokestacks on the outside. We're talking about a molecular-level war against impurities, all driven by some incredibly tough global regulations. The main weapon in this fight is a process called hydrotreating. Honestly, the best way to think about it is like a molecular power washer. They take the fuel, crank up the heat and pressure, and then blast it with hydrogen gas. This literally knocks pesky things like sulfur right out of the fuel molecules. It's the absolute #1 must-do step for making clean gasoline and diesel. Now, let's take that cleanup idea and zoom in, because there's one element they are absolutely obsessed with removing: sulfur. It's one of the most stubborn and environmentally damaging things you can find in crude oil. And just to give you a sense of how intense this is, for diesel to be called ultra-low sulfur diesel, it has to have less than 10 parts of sulfur for every 1 million parts of fuel. I mean, that's like trying to find one specific grain of sand on an entire beach. It's a staggering feat of chemical engineering. But here's the catch. When you rip all that sulfur out, it has to go somewhere, right? It doesn't just disappear. It links up with the hydrogen and creates hydrogen sulfide, a super flammable, really toxic gas. You just solved one problem but created a whole new dangerous one. So how do they deal with it? With this incredibly clever chemical recipe called the Claus process. It's like a two-step dance. First, they burn about a third of that toxic gas, which creates sulfur dioxide. Then, in step 2, they take the rest of the toxic gas and react it with the stuff they just made. And what pops out at the end? Pure, solid, bright yellow sulfur. And get this, they have to be almost perfect at it. We're talking a recovery rate of more than 99.9%. It's amazing. They take a dangerous waste product that they created and turn it into a valuable raw material that goes into everything, from fertilizer to the battery in your car. And that brings us to the second big act in the story. As the world starts shifting away from traditional fuels, refineries are facing a pretty existential question. But they're not just trying to survive. They see a huge opportunity. They are pivoting hard to become massive chemical factories. They're chasing products with much better profit margins than gasoline. Just look at the shift here. In the past, a typical refinery might turn maybe 10 or 20% of a barrel of crude oil into those high-value chemicals that make plastics and everything else. The goal now is to completely flip that. New tech is aiming to convert 40, 50, even up to 80% of that exact same barrel straight into chemicals. So how are they pulling this off? With these new, game-changing crude-to-chemicals technologies. Some of them basically merge the refinery and the chemical plant into one giant integrated unit, skipping a bunch of old steps to get way more chemicals out. Others are redesigning their equipment to do something that used to be impossible: feed crude oil directly into chemical units. So, you've got all this crazy new complexity. How on earth do you manage it all? Well, the next pillar of the refinery's reinvention has nothing to do with pipes and everything to do with data and artificial intelligence. The star of the show here is the digital twin. I want you to imagine a perfect, live, virtual copy of a real refinery unit running on a supercomputer. It's constantly fed real-time data, temperature, pressure, everything, and it simulates exactly what's happening inside. It's basically a virtual crash test dummy. It lets operators try out new ideas and push the limits for efficiency, all without any real-world risk. And the results? They're pretty staggering. By using these AI models to predict when a piece of equipment is going to fail before it actually breaks, refineries can cut their maintenance bills by as much as 30%. And it doesn't stop there. These AI systems can tweak thousands of tiny variables every second to find that perfect operational sweet spot, improving energy efficiency by up to 15%. I mean, that saves a ton of money, and it cuts down the plant's carbon footprint. Okay, this all leads us to the final, and maybe the most critical piece of the puzzle: decarbonization. Refineries know they're huge energy users, and they know they have to change. So they are actively exploring pathways to make greener products. Right now, there are really three main roads they're heading down. First, there's green hydrogen, replacing the hydrogen they make from natural gas with hydrogen made from renewable electricity. Then there's bio-co-processing, basically mixing things like oils made from wood chips right into their existing machinery. And a third, really cool path is advanced plastic recycling, taking old plastic, melting it back down into a synthetic oil, and feeding it back into the front of the plant. They all have huge potential, but yeah, they all have some big technical challenges to solve too. So when you put all these pieces together, what does the refinery of the future actually look like? Well, it's going to be way more of a chemical plant. It's going to be far more digital and optimized by AI, and it's going to be much more integrated into a green, circular economy. This huge transformation from a simple fuel factory to a hyper-efficient, data-driven chemical and recycling hub, it's already happening. The technology is real. But the real billion-dollar question that's left is this: in a world that is demanding change right now, can this industrial giant really change fast enough?